So I'm the one keeping you from your cocktail hour. So I'll go really slow. Just kidding. So I'm not sure how I'm going to follow up on those two nice talks we just heard. But what I want to talk about today is what is innovation within the Lincoln Electric ecosystem, how we choose to develop new products, how we choose to pick new technologies so we are at the cutting edge of development within the welding ecosystem. I want to start off with a video which I pulled off the internet on additive manufacturing. And what you see here is a weld. In my world, it's a weld. They call it additive manufacturing, where they're depositing droplet by droplet and be able to build structures off a substrate in a direct, without any support structures. If you know anything about additive manufacturing, most of the work today which is being done requires some kind of support structure. So this is pretty cool, right? And it's pretty interesting. You can make ornamental and useful pieces out of it. And this is by this group in Europe, and this was in 2014. Now, I tried to see if I can put it in words. So if I have to write an article about this, this is how I would describe it. I have found that metal derived from a fusible metal electrode, passage of current, superposed layers to form various articles of ornamental and useful nature, and it being among the objects of my invention. This is not my language, obviously. So where does it come from? This is from a patent from 1925, and which pretty adequately describes what you just saw in that video. And this is what they produced. So the key takeaway from this, in my mind, is you had an idea in 1925. Ralph Baker of Wilkinsburg, Pennsylvania, had an idea, created an IP around it. It took us just 95 years before we can think of commercializing it. So this big challenge we have is innovation to commercialization is the scale-up challenge. And this is not a Lincoln problem. This is not a Cleveland problem. This is not a Northeast Ohio problem. The US as a country faces this challenge and has prompted the government to put together this National Network of Manufacturing Innovation. How many of you know NNMI? Should check it out, manufacturing.gov. They just put together a strategic plan for advancing manufacturing in the United States. It was released in February. And NNMI.gov has, manufacturing.gov has the links to it. And this NNMI group is the one which created 9 different manufacturing innovation institutes, one of which is right in our backyard in Youngstown, Ohio, which is America Makes, which focuses on additive manufacturing. DMDI is looking at digital manufacturing. LIFT is looking at lightweight metals. So I picked these 3 out of the 9 manufacturing institutes, mainly because it kind of relates to what we do in the field of metals and manufacturing and welding. And they have figured out that applied research, technology development, and workforce development are 3 key areas where you need significant input from the government to solve industry-relevant problems. That's fine, but how do you pick what you want to work on? You want to work on advanced manufacturing, you want to work on technology development, but what do you pick? So if you go to Gartner.com, Gartner came up with this technology hype cycle, and I found this as a good representation of how technologies kind of evolve over time. I mean, as a metallurgist, you talk about thermodynamics and kinetics. This is my kinetic cycle for technologies. Over time, if you look at expectations of a technology, there's a trigger which happens by a brilliant guy, maybe Ralph Baker from Pennsylvania, right? He triggers a technology saying, oh, additive manufacturing is neat, let's work on it. And the expectations rise until it hits a peak. And you can look at, this is from 2012, and 3D printing was at its peak of inflated expectations, they call it. And then eventually people realize that it's not as great as it sounds like. It doesn't have the potential which we thought it had, and it slides down this trough of disillusionment, and finally, eventually reaches a plateau. So as a company, as an organization, how do you pick what technologies to work on, and when do you pick it? Do you pick them when it's at its infancy, or do you pick them at the height of expectations, or do you wait till it reaches a plateau? So from Lincoln Electric's perspective, we look at the external landscape and what changes as a function of time in the external landscape and how we need to react to it. And for us, in the welding world, energy and environment are key players. We heard about sustainability. We heard about oil. We know about the oil prices, which are crashing. So we need to be nimble and adapt to the changing environment and the changing energy landscape, because that's where our products are being fed into. We know that we need stronger materials, harder materials, safer materials. We know that we need faster processes to increase productivity. We know that we need lighter materials to increase fuel efficiencies. So we know that these are the trends we see in the external landscape. And we need to meet that rising complexity of demands and produce products which meet the current demands of the landscape which is around us, of the environment which is around us. And this shows that Lincoln Electric, in spite of what Michael talked about, Cleveland going through the dark ages during the recession, Lincoln Electric has survived and has managed to make the right choices in developing the right products at the right time to meet the demands of the society. And I want to talk to you a little bit about the success stories and how we pick these different technologies we work on. So we call them technology development lanes, and when you look at welding as a problem, we look at it as in terms of performance, meaning higher performing products, higher productivity, or better user experience. And if our new products or new technologies don't fit into one or don't answer one of these challenges, then we typically don't pick them for further development. And the way these technologies have developed for us, Lincoln was an arc welding company, was primarily making motors, was primarily making engine-based welding systems. Now we're into lasers, robots. We're into nano-engineering of materials as well as process control. What you see there in the video there is a droplet being detached, and we come up with algorithms to kind of refine how metal is being deposited. If you look at the evolution of products within Lincoln Electric, we started off with this massive generator-based welding machine on the left and progressed to a digital welding machine where the efficiencies have increased from about 35 to 40% on the left to about 90 or 90+% on the right. And we've done that by investing here in Northeast Ohio, in Cleveland, by bringing in a state-of-the-art clean room facility to make our own PC boards. And we, as a vertically integrated company, try to bring in the technology from the outside, try to build it within the infrastructure we have here in Northeast Ohio. And again, this is all driven towards performance, productivity, and the user experience. We started off as a mild steel coating stick electrode company. How many of you have welded here before? So you know what stick electrodes are. And from simple coated stick electrodes in the early 1900s, now we have a whole platform of welding products, and comprising of materials from nickel, stainless, cobalt, and aluminum. We bought a company called Techalloy, which was based out of Baltimore, and have integrated it within the Lincoln Cleveland ecosystem here. So now we make the nickel electrodes here in Cleveland. We've expanded our consumable portfolio range because of the new materials needed for these new challenges. You're going deeper in drilling for oil. You're going for lighter materials. You need to go to aluminum. So we've invested in an aluminum company which makes aluminum-based welding consumables. What was considered as fire on a stick in terms of welding, we are into fiber lasers now. Again, it's all about performance and productivity. This is what has happened, key areas of progress that has happened within Lincoln Electric, which has transformed us from a medieval metallurgical welding company to a state-of-the-art high-tech, advanced manufacturing company. What's the next step? We are into real-time process diagnostics. The weld fabricator looks at flexible information collection and delivery to configure work practices so that you have complete traceability. This is all about reliability. And this is based on a key technology which you'll see in the Gartner hype cycle on IoTs and augmented realities. 20 years ago, if you had told me that welding and IoT would be talked about in the same PowerPoint slide, I would have laughed at you. But today, we look at these technologies as inspirations to modify the welding process and enhance the user experience for the person who's doing this. We are into virtual welding for workforce training, and if you ever get a chance, try this. If you have welded before, try this for sure. It is just amazing how realistic it is, and independent studies have shown that it makes it easier to train novice welders. You can decrease the welder training time by more than 30 to 40%. You can increase certification rates by 30 to 40%. So we have a huge interest in virtual welder training in countries like Vietnam, in countries like Indonesia, Philippines, where they want to train more welders to keep in sync with their manufacturing capabilities, and they see this virtual welding experience as an easy way of introducing welding to novice welders. We've invested quite heavily in lasers, and we're using this new process. We are developing this new process for additive manufacturing. Again, we consider additive manufacturing as an extension of welding. And we think the core competencies within the company in terms of robotic process automation, process control, high-intensity energy sources, and new algorithms for process controls all lend itself well to build systems for additive manufacturing. This is a slide I borrowed from a good friend of mine who now works for GE, Ed Herdrick, who leads their additive manufacturing efforts. Some of you here may know Ed. He used to work in Northeast Ohio. And they have adopted the hot wire laser cladding process, Lincoln Electric's hot wire laser cladding process for rebuilding crankshafts. These are locomotive crankshafts, huge crankshafts which need repair. And repairing these massive structures is much more productive using this process. Again, going back to this technology hype cycle, if you look at all the different technologies out there, I've highlighted a few of them. The augmented reality for the weld fabricator, the Internet of Things, the cloud computing ability to monitor welding processes and increase reliability. The 3D printing, the additive manufacturing efforts are all at different stages in this hype cycle. So it's not a question of us predicting where these technologies are going to go, but it is the will of the company of the organization to dabble in these technologies at different stages of their life cycle and commercialize certain key technologies and incorporate it into the Lincoln ecosystem. We are not into augmented reality for the sake of augmented reality. We are into augmented reality because it enhances user experience for the welder. We are not into cloud computing because we want to compete with the Googles of the world. But we are into cloud computing because it enhances the foreman in a welding shop to monitor the quality of his work. We are not into 3D printing for the sake of 3D printing to build medical devices. We are into 3D printing because we think we can contribute in these high deposition processes to improve productivity, to decrease cost for the end user. And these are the same end users who are using the stick electrodes, who are using the fluxes, who are using these welding machines for their day-to-day jobs. You walk into an automotive plant, you see these massive dies for die casting. These dies need to be repaired when it gets worn down. We think that the laser hot wire process would solve that particular problem for for that particular application. And it is the same assembly line where we are selling welding machines and welding electrodes for their day-to-day assembly line manufacturing processes. So going back to this NNMI and their institutes, if you look at their strategic plan, they talk about smart factories. They talk about 3D printing. They talk about new materials for lightweighting. And we think we are in sync with the strategic plan which has come out from the federal government in terms of what is needed to rejuvenate manufacturing in the United States. I think that's the reason for Lincoln Electric to be successful, is that we've identified technologies which meet the demands of our customers, which keeps us at the cutting edge of research and development, cutting edge of technology, solving welding problems for our customers today. So I'll end with saying that the evolution continues. What was medieval metallurgy 100 years ago is now truly advanced manufacturing. We still are depositing materials in superposed layers to form articles of useful or ornamental nature, as you saw in that pattern. But we are doing it a little bit more efficiently, a little bit more greener, a little bit faster, with lighter materials, more efficient processes. Thank you.